All right, guys, starting at number 7, in Colorado, we have a 68% chance of having rain in late spring. You decide to observe the weather for 2 weeks, 14 days. Use the binomial distribution to find the probability that it will rain 5 times. So this wants an exactly 5 times here, that it will rain 5 times, not less than 5 times, not more than 5 times, but exactly 5 times. So we're going to use the binomial PDF function in the calculator, which means exact times. Please go back and look at the final review, the review for exam 2, if you want to really get into the binomial PDF and the binomial CDF differences. But for now, this question is just talking about the exact 5 times. So you go to the binomial PDF. That's going to be under distribution in your calculator. Distribution is blue or second, vars. And we're going to find the binomial PDF. Which on my calculator is A. And whoops, I've got to quit out of here first. Binomial PDF. And then, so the number of trials in your, if you have an older calculator, it's going to show up with parentheses. If you have a calculator like this, it's going to ask for the number of trials, and that's we're looking at 14 days that we are getting data for. The probability is 68%, so we're going to put 0.68 for the probability. The number of times we're looking for is 5. And then here we're going to paste it. This is what some of yours will already look like. The way you should type it in is it'll come up with binomial PDF parenthesis, and then you type in 14, comma, 0.668, comma, 5. Okay, then enter. And the probability is 0.0124 is what I wrote down. So I wrote down 5 there. I would accept less, but try to do at least 4 digits. And that's the exact probability of 5 for the binomial. Question 8, the SAT is a test. Well, you guys know what the SAT is. Taken by many students to enter college. The mean of the math section is 500 with a standard deviation of 100. The scores are normally distributed. You don't need to draw the normal curve, but I did for you guys. As you can see, the mean here is 500 and the standard deviation is 100, which means one standard deviation up is 600. So that would be a z-score of +1. 700 would be a z-score of +2, so on and so forth. What is the probability that an individual will score above 650? And so since this is above, it is not an exact value. It's not the probability that an individual will score 650. It is the probability that they will score above 650. So what we want to do is the CDF. Okay. So if you do normal CDF, again, you find that in the calculator under distributions. And what you're going to put first is 650. This does not include the 650. Okay, it's everything above 650. And since we want, so let's say what we're trying to do on this normal curve is find everything above 650, right? So there, the top part, since it's everything above that, the top part is going to be E99, which is the way the calculator can calculate infinity. And on the calculator, what that looks like is to get, so if we start at 650 and the upper, you do blue and then the comma, and that gives you the E99. And the median, or the mean, I'm sorry, was 500, and the standard deviation is 100. and you get 0.0668. Okay. What is the probability that an individual will score, sorry, below 475? You just do the same exact thing, but you change it. So your lower bound is going to be negative. So you do the same thing, but you put a negative infinity. The upper bound is 475. You have the same median. You have the same standard deviation. Okay. What is the probability that an individual will score between 415 and 635? And in this case, we found if something says between, you get a better answer if you find the z-scores and do it this way. So we're going to still use the same normal CDF, but you will get a better answer if you use your z-scores. So to find z1, I put the observed 415 minus the mean 500 divided by 100, the standard deviation, you get negative 0.85. To find z2, you put the observed top upper bound, so 635 minus 500 divided by 100, so you get 135. So what we're trying to do is find the probability that an individual will score between negative 0.85 and 1.35, positive 1.35. So our lower bound is negative 0.85, our upper bound is 1.35, and since we're using standard scores, we're going to use 0 as the mean and 1 as the standard deviation. And this is the probability that you're finding in between them. You could probably always get a more closer score by finding the z-score first. It just so happens that's exactly the same for A and B. Find the score that will mark the 95th percentile. So this time, since it gives us an area, we need to do inverse norm on the calculator to find the score. If it gives us an area, we want to find the score. So what we're going to do is it still under distribution? Yeah, distribution 3 inverse norm, because it gave us the area. So the area is 95% or 0.95. You can't use percents in the calculator. And then I'm going to change this to be 500 and this to be 100. And we get, okay, approximately 664.48, but since it is a discrete, since scores are discrete values in the SAT, we're just going to use 664. We'll round that down. What's next? Okay. The U.S. Small Business Administration provides information on the number of small businesses for each metropolitan area in the U.S. We know that the population distribution is normal with a mean of 12,485 and a standard deviation of 21,937. So I wrote those down just to remind myself. Mu 12,485, sigma, or the standard deviation, 21,937, that's for the population. Find the probability that a random sample of size n equals 36. Oh, and I had here highlighted also the population distribution is normal, which means we can do all of our math correctly. So n is 36, and find the probability that a random sample size will have a mean number of small businesses greater than 17,000. So because it is normal, we can keep the mean. The mean's going to stay the same. And to find our standard deviation, we use the little formula, sigma divided by the square root of n. Our sigma was 21,937 divided by 6. So we got our new sigma is, standard deviation is 3,656.16. Now we need to find our z-score. So we want to find our z-score based on, we want to find it greater on our sample than 17,000. So 17,000 is our observed, or what we want to know, minus the mean. So it's the same z-score I just talked about above, divided by your standard deviation of your sample. So our z-score for that was 1.23. I'm going to pause here. I want to see something before I show it to you. Yeah, I just wanted to make sure I knew the right buttons to push before I showed you on the calculator. So just to quickly go over the long way to do it, the way I did it by hand, this is our z-score, 1.23. You can put it into the normal CDF. So you're trying to find the percent above, and you would come up with your answer. If you wanted to use your calculator, you have your calculator, you go to Stat, Tests, Z-test number 1, and we have the stats. So what we're going to put in is our mu, which was 12,485. And this will do all the calculations for you. Our original sigma, which was 21,937. And our answer is going to be a little bit different because the calculator does not round. It will use all of the decimals. The X bar, the one we are looking at, is the 17,000. Our N, 36. And we are looking for greater than. And we want to calculate. Okay, so there's our Z value, 1.234899941. And the calculator uses that entire decimal, which is what accounts for the probability of it being larger than, which is a little bit different. So 0.1084. Okay, so you can definitely use your calculator for this also. Part B, find the 90th percentile of sample mean among those 36 cities. And here you just do the inverse norm of your area being 90, and you get 1.28. Okay, but that's just our standard score. What we want is to put it back in and find the actual value that would be. So you just put it back into the z-score. Normally it would be the z-score is equal to the observed minus the mean, the observed mean minus the actual mean divided by your standard deviation. But in this case, what we're looking for is the observed score. It wants to know what score will give us a z-score of 1.28, which would be in the 90th percentile. So you just solve it backwards. We're going to take 1, so just for those of you that need it, you can skip forward if you don't. Just to undo this, I'm going to take 1.28, multiply it by 3656.16. That's the first step. And then add 12,485. And you get 17,164.88. I just left it as a whole number. Although I guess since it's a mean, you could do a decimal. I'm fine with this though. What is the probability of a city having more than 30,000 small businesses? So here, okay, we have 30,000. We put it back in to find our z-score of 0.8. Go back, do the normal CDF. put that in. You get your number there.